This video is about the formulas for sine of x plus y and cos of x plus y and their use in various trigonometric identities that are useful for both preparation for examinations and in general manipulation of the various sines and cosine expressions. Let us begin with just the statement of the formula. We will not entirely derive the formula on geometry basis in this video, but you will have an occasion to see how the formula can be obtained using algebra. The expression is sine of x plus y, that is, if sum of two angles and we take the sine of sum of two angles, this will be equal to sine of x and cos of y plus cos of x times sine of y. So using that, x is equal to y, we will get sine of 2x is equal to 2 times sine x cos x. Now cos x can be written as square root of 1 minus sine square x. This transformation leads us to an equivalent formula for sine 2x as 2 times square root of sine x minus sine cube x. We can use this formula to find sine of 75 degrees angle. Since 75 can be written as 30 plus 45, we will have sine 75 equals sine 30 cos 45 plus cos 30 sine 45. In our previous video, we have shown how sine 30, sine 45, cos 30, cos 45 can be calculated. To look up that video on our channel, look for trigonometry ratios, the video trigonometric ratios. Now sine 30 is half and cos 30 is root 3 by 2. Sine 45 is square root 1 over square root of 2. Cos 45 is also 1 over square root of 2. If we substitute those values, we get 1 plus square root 3 upon 2 root 2 as our answer to sine of 75. You can calculate that using cos of x plus y, the cosine of the sum of two angles, equals cos x cos y minus sin x sin y. Towards the end of the video, you will know how to derive this formula algebraically. This helps us find, for example, cos 75 in the similar way that we found sine of 75. We will not complete the calculation here. You can try and to imitate the last slide to find cos of 75. Let us calculate cos of 2x using the formula for cos of x plus y. Since 2x can be written as x plus x, we will have cos of 2x equals to cos square x minus sine square x, because this same thing can be written as, since sine square can be written as 1 minus cos square x, we can write it as 2 times cos square x minus 1, or writing cos square x as 1 minus sine square x, we get an alternative expression 1 minus 2 sine square x. So these are very useful things because this type of rearrangement, expressing the same thing in different forms. So 1 minus 2 sine square x is a different form of cos 2x. 2 cos square x minus 1 is a different form of cos 2x. We are able to substitute these type of things to get different type of expressions. And our familiarity with these type of expressions and manipulations is of importance in dealing with trigonometric functions. Let us use the last two expressions that we obtained for sine 2x and cos 2x to obtain the expression for sine 3x. So sine 3x is sine of 2x plus x. This gives us sine 2x cos x plus cos 2x sine x using the expression for sine of x plus y. Now cos 2x, we can use the expression 1 minus 2 sine square x for cos 2x. So the second term cos 2x sin x becomes 1 minus 2 sine square x times sin x. And the first term sin 2x, we can use the expression 2 sin x cos x. So the first term becomes 2 times sin x cos square x. The cos square x has an equivalent expression 1 minus sine square x. Substituting that, we see that sin 3x becomes 2 times sin x multiplied by 1 minus sine square x plus 1 minus 2 sine square x whole multiplied by sine x. If we expand and collate the terms of sine x and sine cube x that we obtain, sine 3x becomes 3 sine x minus 4 sine cube x. Similarly, we can look at cos 3x using the expression of cos of 2x plus x. We will have cos 2x cos x minus sine 2x sine x. Now the cos 2x has an equivalent expression of 2 cos square x minus 1, which we can substitute. So the first term becomes 2 cos square x minus 1 times cos x minus 2 times sin x cos x, because that is the equivalent expression for sin 2x times sin x. So we get 2 sin square x cos x. Now sin square has an equivalent expression of 1 minus cos square x. We can use that instead of the sin square x. Collating the terms of cos cube x and cos x that we obtain, we see that cos 3x becomes 4 times cos cube x minus 3 cos x. If you are familiar with the exponential function in complex numbers, the expression of e raised to ix is equivalent expression is cos x plus I sin x. So e raised to ix is equal to cos x plus I sin x. E raised to I times nx will be cos nx plus I times sin nx, where I is the square root of minus 1. Now we are dealing with complex numbers. E raised to I nx is also e raised to ix raised to n. So equivalently, we will have e raised to I nx as cos x plus I sin x whole raised to the power n. Now this is the one from which we can derive many of the trigonometric identities related to the what we have already seen. In order to move further, we require the expression of binomial theorem, which state that x plus y whole raised to n equals x raised to n plus n choose 1 x raised to n minus 1 y plus n choose 2 x raised to n minus 2 y square plus n choose 3 x raised to n minus 3 y cube, and so on, plus n choose n minus 1 x y raised to n minus 1 plus y raised to n. If you are not familiar with the binomial theorem, please watch the video Distributive Law and Algebraic Identities available on our channel. This is always a very useful expression which is required in sciences, all sciences and engineering. You should know it. So we can restate the e raised to in expression as cosine x plus I times sine nx is equal to cos x plus I sine x whole raised to n. This, along with the binomial theorem, helps us in getting the identities that we require. Since in the expression for cos nx plus I sin x, cos x is the real part of that complex number cos x plus I sin x, and sin nx is the imaginary part of the number cos nx plus I sin nx, we are able to write cos nx equal to real part of cos x plus I sin x whole raised to n, and sin nx as imaginary part of cos x plus I sin x whole raised to n. Since cos x plus I sin x whole raised to n can be expanded using binomial theorem, we are able to quickly get the expressions for cos nx and sin nx in one form. Of course, there are many equivalent forms in which that expression can be transformed. Let us look at that more carefully. So cos of 2x will be equal to real part of cos x plus I sin x whole square. Now a plus b whole square, you know, it is x square plus 2ab plus b square. So you will get cos x whole square, which is cos square x written as cos square x, plus 2i times sin x cos x plus I square sin square x. That is the expression for cos x plus I times sin x whole square. The real part of this is the cos square x minus sin square x, because I square is equal to -1. And the imaginary part is the 2 times sin x cos x expression. So we get cos 2x equal to cos square x minus sin square x, and sin 2x is equal to 2 times sin x cos x. These were the expressions we had used previously in our video, in this video. There is more to come on this topic in later videos. Please stay subscribed.